Hey everybody, and welcome to the last lesson of PreCalculus, section 11.5, systems of nonlinear equations. So what we're going to do is we're going to take what we've been doing with conic sections, and we're going to put them together into systems of equations and kind of do what we did back in chapter like 9 and 10 when we were solving systems. Now, something to note about these is you can get a variety of options. You can get between 0 and 4 solutions. So here's an example of getting no solutions, and you can mix and match them. You don't have to use these combinations. But if you can get 3 solutions, so like 1, 2, 3 solutions in this one, 2 solutions, or you can even get like 4 solutions. Ooh, very exciting. You can't get 5. The maximum that you can get is 4 when you put both of these two together. So when you're solving them, there's a couple things to worry about. I'll tell you which one to use, so you won't have to worry about like, well, am I supposed to use elimination or substitution? The general idea is if the variable has the same power, then you should use elimination. And when you're using substitution is when your variable powers aren't matching up, so you're not actually able to eliminate. Eliminate is the better option. When you're doing substitute, you also need to substitute back into the lowest degree equation. You can't just substitute wherever. And then you need to check for extraneous solutions. Elimination doesn't create extraneous solutions, but substitution does. So you need to be careful there. So let's try it out. Let's do a little elimination problem. So I want to solve this thing using elimination. So what I want to do is I want to get these x's to cancel out. So I'm going to get them on the same side of the equation. So I'm going to bring this guy over there. So we'll get negative x squared when I brought it over to the other side, and plus y equals, and now it's just 0 because it was x squared plus 0 and brought the x squared over. Now, all we have to do is add these two equations together. So the x squared plus a negative x squared is no more x squareds. We get a y minus 2 squared plus a y, because that doesn't really match. We've got this, and this doesn't really match with anything, so it's just plus a y. And then 4 plus 0, that's 4. Now, in order to finish solving, I need to FOIL this thing to combine it with the y so I can get a nice quadratic, and then I'll solve what's left over with that quadratic. So when I square the binomial, I get y squared minus 4y minus 4 plus y equals 4. Okay, now that we've got that, I need to get it equal to 0, and I got to clean up my equation a little bit. Oh, I missed a plus right there. I'll get that. So minus 4, and we're going to combine these like terms. So we get y squared minus 3y equals 0. My left-hand side is now a GCF factor. I can factor out a y. So then by the zero product property, y equals 0 from this first one, or y equals 3. So this looks like it's going to be a case where we get 2 solutions. Right now, it could expand to more. We don't know. It could go to a maximum of 4, remember. So we can substitute back into either equation. I'm going to do the first one because it's easy. But we've got to check both ones. So y equals x squared. Y equals x squared. So we got to put in 0, and we've got to put in 3 and see what we get. In the first equation, 0 equals x squared. When you square root both sides, you get 0 equals x. So x just equals 0. So our first solution is at 0, 0. Now on the other one, we're going to substitute in that 3. So we got 3 equals x squared. When we square root, we get plus or minus the square root of 3 equals x. The plus or minus didn't really matter with the 0, but it does matter with the square root of 3. So this produces 2 additional solutions. So it is the points of 3 comma square root of 3. I don't know why I made that brackety thing there. 3 comma negative square root of 3. All right. So we end up getting 3 solutions in this equation. 0, 0, 3, comma, square root of 3, and 3, comma, negative square root of 3. 3 solutions for our equation. Neat. Okay. Now, this next one, something special happens that I wanted to highlight. This one actually has a problem. You can get 0 solutions or infinite. No, we actually take that back. We can't get infinite solutions. We can get no solutions. So I wanted to show you what that one looks like. We need to eliminate. So those y's look good to eliminate with. We get x squared plus x, and that y minus y is 0. 2 minus 5 is negative 3. We get x squared plus x plus 3 equals 0. Now this thing we would need to factor, so we need something that multiplies to be 3 and adds to be 1. That doesn't factor. So we can use the quadratic formula. Now I'm just going to speed things up because I don't want this video to go for forever. But if you work through your quadratic formula, you'll end up with this. X equals negative 1 plus or minus the square root of negative 11 over 2. That's an imaginary solution, meaning they have an imaginary intercept, which is not real. So we have no real solutions. You may get things that are imbalanced, kind of like what we did back in chapter 9, where it was just like 2 equals 7. That was no real solutions. This one is there. You could get imaginary stuff, and if you get imaginary stuff, the graphs aren't touching. They're touching on the imaginary axis, which is kind of like going out of the paper, but doesn't actually have an intercept, so we don't have a solution. Final example of the school year, everybody, solving the system using substitution. Now, this one, elimination is not going to work. If you try to add or subtract these two equations from each other, since these exponents aren't matching, those won't eliminate. Same thing with these y's, they won't eliminate. So we're going to have to use substitution in order to solve this thing. So what I'm going to do first is I'm going to isolate one of the variables. I don't want to try to isolate these squareds because that's going to be a pain. So I want to do x or y. I'm going to go after y just because. So I'm going to convert this equation into y equals negative x plus 5. Then I can easily take this and plug it in right there where that y is. So I'll rewrite the equation as x squared plus parentheses and a squared equals 13. And I'll put that negative x plus 5 in there. Ace. Now it's a quadratic thing, so I'm going to do quadratic solving stuff. I'm going to square that binomial. So that is going to be, 25 minus 10x. I'm just cheating off of my key. It's the end of the year, man. Leave me alone. So when we square that binomial, we get 25 minus 10x plus x squared. It's just foiling. Then we want to combine like terms and get this thing equal to 0. So we'll subtract a 13, combine these two. So we get 2x squared minus 10x plus 12 equals 0. Now, I've got this 2 with the x squared, and that makes my factoring really tricky, so I really don't want to do that. But I do notice all of these things are even. Ooh. Don't divide by x. If you're tempted to divide by x, don't ever divide by x. That's not a good solving step. It removes one of your solutions. But we could divide everybody by 2. That'll just make these big boy numbers into little numbers. X squared minus 5x plus 6 equals 0. Ooh, that's a lot easier to factor. I like it. So x squared, what multiplies to be 6 and adds to be 5? Well, it's negative 2 and negative 3. making our x's 2 and 3. Okay. Now we have to take those and we need to put them into the lowest degree equation. We don't want to take these two and put them into the top equation. That's not going to be good. That's a higher degree equation. It's got bigger exponents in it. This bottom one has smaller exponents in it, just one. So we're going to use that one. So I got to put 2 and 3 into those two equations. So x plus y equals 5, x plus y equals 5. Plug in a 2 and plug in a 3. So 2 plus y equals 5, y equals 3. Oh, don't box that, because that's not actually my answer. Here, let me get out of the way. So we get a point here at 2, 3. And the other one, we got 3 plus y equals 5. So we subtract a 3, we get y equals 2. So this point is at 3, 2. Woo! And that is our last example of the school year. Thanks for sticking with me for all these videos, and have a good rest of your day.